Well, hello, welcome. This is lesson 2, types of graphs, day 1. This is the Edpuzzle annotating graphs video. Make sure that you finished everything from lesson 1 before you're doing anything with this video. Okay, what we're going to be going over, how do you break down a graph and different types of graphs? Graphs are worth, they're pictures, so they're worth 1,000 words. Sometimes in news articles or scientific papers, whatever it is, most of the time, I go straight for the graph because I don't even have to read anything else. I literally just have to look at the graph because it's summarizing everything that they're saying. So it's super useful and gives lots of good information, but only if you know how to read it. All right, so the first thing that you have to notice is that just what type of graph is it? So the graph to my left, I know that this is a bar graph. Bar graph, it literally looks like I have different bars or like columns here. In every graph, I try to pick out what are the variables in here. Before I pick out what it's saying, just like, what am I looking at? All right, so the independent variable is normally on this bottom axis, the horizontal or the x-axis one. So the independent variable, I'm seeing tobacco, alcohol, prescription, blah, blah, blah. So this just looks like types of drugs that are being used. I also see the title says drugs deadlier than marijuana. This was in 2011. Remember, the independent variable is the variable that you as the scientist can change. So if I were doing an experiment, like I could change the type of drug that I was looking at. The dependent variable, that's the thing that you don't have control over. It's just what happens as a result of the independent variable. This, if I look at the y-axis, which is normally where the dependent variable is, I don't see any labels, but I have noticed here that under the drug it says deaths. So the numbers that are here, these are the number of deaths that have occurred because of that drug. All right, now I know what I'm looking at. My trend. So trends are just what is the story that the graph is telling. There are so many trends that can occur in a graph. You can pick out different things, especially with like things that graphs that show multiple things. So this shows multiple columns. The trend that I'm going to go for is normally the most blatant being most obvious. So for me, it's this tobacco death column. I see that the bar is the highest, the number is the highest. So my trend would be the number of tobacco deaths was the highest compared to any other drug. It's also interesting, another trend I think that is interesting is that tobacco and alcohol, the two legal drugs, have the highest number of deaths. Now, this was taken from 2011, so things, of course, may have changed since then, but I think that it's interesting that the two legal drugs have the most deaths. Not to say that these don't have significant deaths, but it's interesting that drugs that are legal are also causing people to die. Okay. Let's keep going. All right, public opinions of LGBT issues. All right, this type of graph, this is a line graph, or sometimes we call it a multiple line graph because you can see there's more than one. Line graphs normally show things over time. Time is always the independent variable. You can see at the bottom at the x-axis, I know it's really small, I'm so sorry. It says 1970 to 2015. That's time. I know independent variable is something you can control. As the scientist, you can control what time period you are choosing to look at. The dependent variable. Again, the y-axis is not labeled. I don't know why they do this, but the lines are labeled. So that's another way that you can look for the dependent variable. So over time, like, what are they looking for? So I see that the lines are labeled always wrong, not wrong at all, sometimes wrong, and almost always wrong. I still don't know exactly what they're talking about until I look at the title. The title is Public Opinions of LGBT Issues. So my dependent variable would just be public opinions of LGBT issues. So first, for any variable, you would look at the axes for them to be labeled. If not, then you have to look to see if the lines are labeled or something there's labeled on the graph. And then you can also look at the title. All right. Trend. Again, I'm going for the most obvious. I'm going to look at this top line here. So this says always wrong. So I see that between 1970 and 2015, because that's when this study took place, the public opinion that LGBT issues were always wrong decreased from, let's see, it started around, I would say this is like 75% to, and then this is like right under 50%. So I would say maybe this is like 45%. Which is kind of a, I mean, that seems like a lot. Like, it means public opinions of LGBT issues are changing. Okay. Last kind of graph we're going to go over, this is called a pie or a circle graph. These just show basically how the parts relate to the whole. So here there's not really like an independent dependent, there's no like relationship between that, but I do want to point out the variable. The variable I'm seeing is in the title. It's the leading causes of death. My trend, I'm going to look at my biggest piece of pie here. This is telling me that heart disease has the largest percent, meaning it is the leading cause of death. All right, so this trend is more like of an observation that you're seeing. What I want you to do now is, we've just gone over a number of practice about how to break down these graphs. Here, you're going to be doing the same thing. You are going to pick 3 line graphs, 3 bar graphs, and 1 challenge graph to annotate, and you're going to annotate just like we just did together. There are a number of graphs here, so please pick the one that you find the most interesting for each section. And get started and have fun.